very much, and welcome everyone to our first seminar of 2021. So today I will introduce PDS Square, which stands for Privacy Preserving Decentralized Data Sharing System. So this is a project that I'm working on together with Ioannis and Thomas. So yeah, I didn't invent all the things in the slides. So yeah, it's more of a shared work. But so let's start with a motivation. So what do we want to do? Well, I think we're all aware of the fact that data collection is becoming more and more important and more problematic. And this is because data analysis and machine learning, as the year passed, they are driving more and more value for companies in many kinds of sectors. They are seeing higher and higher adoption. And these are very data-intensive tasks. So, of course, if you need these tasks to drive value generation, then data collection becomes fundamental for your business or for your activities. And so you have to collect as much as that data as possible. And this diagram here, very complex diagram, presents you how it works right now. So the data flows from the users to the companies that collect them. And this creates a lot of problems. So most problems are from the user side, from the user perspective. So you lose control over your data because once your data has moved to the company, you don't know how it's being used. You don't know where it is stored, who is accessing it, which third parties might be getting it, unless you read the privacy policy and, of course, assuming the company follows it. So you don't know when, how, or by whom it is used. And this also implies that there are no privacy guarantees for you because even just the company you gave the data to, you don't know what kind of tasks they run on it. You don't know if your privacy will be leaked, if actual people at that company will be able to see something about you. And also, if we say that this data is generating value for these companies, well, then maybe the user might want some of this value to be shared back, given that the user generated this data. But this is not what happens. You are not rewarded for the value of your data. But this actually also generates problems from the business perspective. The biggest problem there is that this poses a high barrier to entry because you need a lot of data to have competitive models, to have competitive services based on the data. And this, of course, makes it very hard for smaller organizations, for newer companies to start competing with those few huge market leaders. But this also, even for the market leaders, creates problems, creates legal burdens because they are working with sensitive data that needs to be protected. And also infrastructural cost because collecting, storing, and analyzing huge amounts of data in a data center creates quite some, it's not really a very easy task, and there is a lot of research also going on there. So do we have alternatives to this? Well, we have some. So there are data marketplaces, mostly designed for IoT, who can help in this regard. So how do they work? Well, how they work is that within the marketplaces, the users can sell their data to the companies, which will get access to the data only after paying a reward to the user. So the user finally gets a share of the value, depending on how much the company is willing to give, how much the company values that data. However, most problems are still there because once the company gets a copy of your data, then again, that copy of your data, they can do whatever they want with it, create more copies, share it, and do any tasks, run any tasks on it. So you still don't have any control over how the data gets used, and you don't get any privacy guarantees. We did one step forward, you get some reward for the value of your data. But then we will add here one more thing that we didn't put before, And it's the fact that most of these marketplaces do not present a user-centered design, but are rather designed around the needs of, here I put it as SMEs, small and medium enterprises, but the idea of people who produce data kind of as their business. So it could be just me, but let's say I made a small weather station with a Raspberry, and I'm selling that weather data on these IoT marketplaces. So it's not really meant for the single user who creates data by using apps. It's more for people who generate data to be sold. So it's kind of not the correct solution for what we are trying to do. And this also on the organization side, this lowers the barrier to entry for smaller businesses, because now you don't need to collect the data. You can just buy it when you need it. So you don't need to spend years collecting tons of user data or guessing which data you will need. When you need it, you just buy it. But still, once you buy it, if it's sensitive data, you have to protect it, and you have to have the infrastructure to manage it and analyze it. So still, there are many problems that are not solved, but the marketplace idea is going in the right direction. So what we suggest with PDS Square, from an extremely high-level perspective, is to have this marketplace, PDS Square, and we have our users, which we call providers, that send data to the marketplace. And then we have the consumers, we have the companies who, instead of getting the data directly, what they do is that when they want to run a task on a data analysis or machine learning task on the data, they submit their task to our marketplace. And they send a reward to the users whose data they are using within PDS Square. So this actually allows us to have all the properties that we were looking for. Users maintain full control over their data, because every time a company wants to run a task on their data, they need consent from the user. So a user always knows what is being done to their data. And also we provide strong privacy guarantees, because the company does not actually see the data. The task is being sent to the data, not the other way around. We, of course, still provide rewards because it's a marketplace. And also, although it's not obvious from this slide, but our marketplace, and we will see it, has a user-centered design that is really meant to fulfill the different needs that different individual users can have. And also, from the organizational perspective, we still have lower barriers to entry as before. You can just buy the data you need. But also, you have no legal burdens or lower legal burdens and lower infrastructural costs, because now the tasks are being run in PDS Square and not on the company side itself. And of course, this begs the question, well, oh wait, I forgot. Also, this provides strong intellectual properties protections for the company, because well, basically it's also not obvious from this slide, and we will go into more details. But the idea is that we make sure that the code of the task and the results and other details that might be IP property of the company, they do not get leaked to other companies or to the end users, but they stay visible only to the company itself. But then, as I was mentioning, you might ask, how do we run this? And so we also have a third kind of player, a third kind of actor in the system other than our users and organizations. And that will be those that maintain the internal infrastructure of PDS Square. And those, of course, will also need to get a share of the rewards in exchange for their service to the marketplace. So now that we've seen the motivation and the requirements that we have, let's go through the overall general architecture of our platform. So first of all, we have our user, which, as I said, we call them providers, that produce data and they store them somewhere. So we call this a storage subsystem. On the other side, we have the consumers which are these organizations that want to run tasks on the data. And in the middle, we have what we call executors, which are basically the places where the data and task meet and where the task is actually run on the data. And finally, we have a governance layer, which is responsible for maintaining the entire system, for verifying and doing the bookkeeping for all these workflows that are running in the system, and also auditing that everything is being run correctly, no one is cheating, and no one is doing something that can harm the system or go against what are the requirements of the system. So I will now give an example of how a typical task would be run in PDS Square. So step 0, of course, the providers must have produced some data and put it in their storage system. The consumer, what it does, the consumer has a task to run, and it notifies the governance layer, look, I have this task to run. The governance layer, what it will do, it will notify the storage subsystems of every provider saying there is this new task available. And now here comes one important thing. If the task says, I want to run some data analytics on Fitbit data, of course, the provider should provide Fitbit data. So the storage subsystem now verifies that the specific provider has data that is eligible, so Fitbit data in this case. If that's the case, the provider is notified of this and can choose whether to accept or decline giving their data for this task. If they accept, they will tell the storage subsystem to accept this and to forward the data, the eligible data, to an executor, an available executor of the choice of the provider. So the data will be forwarded. And each executor that receives data for a specific task will then notify the governance layer, look, I'm participating in this task, and I received this data from these providers. So the governance layer will know each executor which provider's data it is processing. So once all the conditions for initiating the task are met, the task can actually be started. And the executors will then talk to each other and will, together in a decentralized manner, produce the final result of the task. And we run the task on the local data and aggregate that. And once this is done, the governance layer will be notified, and the consumer will be able to fetch the results. So this is the general schema of how any task will be run in the system. And here I just provide a sequence diagram that can be useful later if you have any questions on how this works. But then, as we've seen, there are these 5 components, these 5, we call them roles in the system: data producer, storage, executor, data consumer, and governance. And one important thing about PDS Square is that it is a very modular and flexible architecture. So what do we mean? What we mean is that this is a general system that can work for many use cases and can have different implementations using different technologies underneath it. So for example, this system is completely data independent. It does not matter what kind of data you have or whether you are really individual user, which is what is the focus of our research, or an organization producing data. That will also work in PDS Square, even though it's not the focus of our research. And on the workload side, with some caveats, but any data aggregation task could be run in this system. So there are no specific limitations, although there are some requirements to ensure that the privacy of the user is guaranteed. Our focus will be mostly on machine learning tasks, but any tasks could be run on this. And then the internal components could be implemented with different technologies, as I said. Different users might have different needs and choose to have local storage or cloud storage or some decentralized file system like IPFS for storing their data. At the executor level, there are different ways to aggregate information, to aggregate data from different executors. And there are different ways to ensure that the executors run the code in a privacy-preserving way to prevent leaks of information from the users. And finally, the governance layer could be built on top of one of several technologies, most likely blockchain technologies. But even there are multiple options in the blockchain domain. And so our first core idea was to have an architecture that can be implemented in different ways and can be extremely flexible. And later on in the presentation, for the boxes that are red, I will actually talk more about it, about what technologies can be used, what are the requirements, and also which technologies we felt were the most suitable to implement these. So, but before going to that, I want to talk about user-centered flexibility, because this was something that we sneaked in the requirements halfway through the motivation part. So user-centered design means that we want to take into account the necessities of the users and how the users might want to use this platform. And so if you check this diagram, let me get a pointer. If you check this diagram, you can see actually data producer, storage, and executors. We put them in a box called the producer stack, because this is the stack where the data gets moved, starting from the producer towards the executors. And so this is a quite important and sensitive part for the user themselves. So what can happen is that, as I said, these are separate roles, but separate roles does not mean that they must be implemented by separate entities. So a data producer could, for example, decide, and let me just pull on this picture, a data producer could decide, look, I produce data in my smartphone. I also store the data in my smartphone. My smartphone is also my storage subsystem. And look, my smartphone is also my executor. My smartphone will participate in the execution of the task without actually sending the data anywhere else. So this is like the most privacy-minded way of doing things. Everything stays local to your phone. You could, of course, add some variations where instead of your phone goes to some machine in your living room, which will act as a storage and also executor. But you could instead decide that it's more convenient for you to give up some of the hardware control and just to use an external executor, like a third party that provides this service, or even an external service, an external storage provider. Like now there are many storage providers on the cloud. This could kind of modify their business and provide storage for your data and provide also execution for your data to guarantee that your data can participate in PDS Square and you can get rewarded for that. And PDS Square guarantees that you can do all of these and still keep your data private, even when you choose to outsource your data. You can still keep a high degree of privacy. You don't have control of the hardware, but still we use technologies to provide strong guarantees, even in these cases. So yeah, it's very, very flexible, and it allows different players to really choose what is the best setup for them. But now enough talking about marketing for our platform. Let's go into the more technical parts of it. What are the building blocks that we need to implement these? So the first building block I will talk about is privacy-preserving data processing. So we have a lot of private information in our system. The first and most obvious one is, of course, the data of the providers, which is here indicated in green, which moves towards the executors. But on the other hand, we also have the intellectual property of the consumers. So for example, some parts of their data analytics tasks or some part of their machine learning models will be possibly a trade secret that they don't want the other market leader in the sector to also know. So this is also something that must be kept private. And keeping this private also means keeping it private from the rest of the platform, the rest of the actors here, who could be anyone else. So this means also that the storage layer should probably not see your data, especially if it's a cloud provider that provides you storage. And also, the executors should probably not see your data, and they should probably not see the code that is being run on your data. Because again, this could be a third party, and how can you trust this third party? So the obvious solution to prevent people from seeing things is to use encryption. Let the green thing be encrypted by the provider and the blue thing be encrypted by the consumer, and no one can see anything. But this begs the question. The executors need to run the code, the task on the data. How can they do that if they can't see any of them? Well, privacy-preserving data processing tries to answer this question. And it turns out it's a quite large field with a lot of different techniques being investigated. And so it is not really my specialty to go into the details of this. So I will just introduce what is the most suitable technique that together with Ioannis and Thomas, we have identified for this part, which is trusted execution environments. So a trusted execution environment, in few words, is an isolated, tamper-proof hardware black box. You can think of it as a small component within a CPU that has been designed by the producer of the CPU to be isolated from the rest of the system. It is impossible to see what is happening inside it, even if you have actual access to the rest of the computer. So even if you go probe the RAM of your computer, you will not be able to get the data that is being used within this hardware environment in your CPU. You would have to go and break the CPU to find out. All communication that move outside or inside, that cross the boundary of this environment, they are encrypted with encryption keys that are only present within the environment itself. And it is possible to verify that the code that is being run in this environment is actually the correct code. So the environment can tell you, I'm running this code with this hash, and you can verify that the hash matches and that the code has not been modified. So all you need to consider this trusted execution environment, or TEE, as secure is to trust that the company that built the CPU with the trusted execution environment in it. They do not have a very good track record as of now, but there is a lot of effort going on and a lot of interest by many companies on these trusted execution environments. So we believe that in the next few years, it will become a very strong option for us. So yeah, this we believe is the most suitable technique for privacy-preserving data computation. Although again, I must stress, it's not the only one. I just won't go into the details of others, such as homomorphic encryption or secure multi-party computation. They have different trade-offs, and we believe they are not as good as TEEs for this purpose. But then let's move on to a different building block, decentralized aggregation. So what is the problem here? Well, we have a consumer and we have a bunch of providers. And how does the consumer access the data of the providers? Well, the data is moved to the storage subsystem, and then the data is moved to the executors, and there could be a ton of executors with different providers' data. And the question is, how do we get the result that the consumer wants? Because here we have the data split in a lot of separate places. So again, we are talking about the executor's role. So each executor internally can only compute partial results based on the data of its own providers. So like this small executor here will only be able to compute results from this provider. And we need to merge this. How do we do it? Well, the first solution, of course, could be let the consumer do it. Just each executor sends its partial results to the consumer, and the consumer merges them. In machine learning, this would be called federated learning. and is actually a very well-studied technique. However, this has a bunch of problems. First is a scalability problem, because if we have thousands, hundreds of thousands, maybe millions of executors, and we have one central location that needs to actually do the aggregation, that's really not an efficient way to do it. It will become a bottleneck in terms of both computation, but also bandwidth, because everyone needs to transfer a lot of data to the consumer. It will also be a fairness, transparency, and auditability issue, because the consumer is a black box outside of PDS Square. We don't know what's going on internally there. We don't know if the aggregation is doing in a fair way. We can't audit what is going on. And the third obvious problem that derives from this is that we do not know if the privacy of the user will be preserved. Again, look at this specific executor. This executor only has data from one provider. So the partial results here will contain a lot of information that is specific to this provider. There is no any plausible deniability, like here, each provider could say, no, the results have been skewed by this other provider, so it's hard to say what is mine. But here it's pretty clear, it's only one provider providing the data. So we need to avoid this. And well, the solution to this is decentralized aggregation. And one technique to do this for machine learning, which I brought here because it's my specific research field, is gossip learning. So what does this require? Basically, it works by using a peer-to-peer protocol based on gossip communications to allow these executors to basically do the work internally by communicating with each other. This allows us to have a very efficient usage of all the resources. We use the computation of all the executors, computational power of all the executors, and we use the bandwidth of all executors at the same time. Every single link between them can be exploited in parallel. And also, because we are running on the executors, which use privacy-preserving data processing, as we already discussed, we can guarantee that we are running the correct aggregation, that everything is being done fairly, and that no data is being leaked. Because again, if, for example, we say trusted execution environments, even the owner can't see what is going inside that environment. So decentralized aggregation is definitely the way to go. And so we believe, in particular, gossip-based techniques for aggregation, not only gossip learning, which is specific for machine learning, but other gossip-based aggregation techniques for other data analytics tasks can also be used. And they are the best way to achieve this. So the third component, third building block that we should consider is blockchain technology. Because now we are moving to the governance layer. And of course, if we want a decentralized marketplace, then blockchain technologies represent the natural solution. Most IoT data marketplaces out there, they are based on various kinds of blockchains. So what exactly do we need for PDS Square in the governance layer? So what are our requirements? We need, first of all, complex, powerful smart contracts. Because these smart contracts, they need to manage the workflows that I presented earlier. They need to make sure that every task is submitted, notifications are sent, bookkeeping of all the executors and providers who are participating, management of the rewards. So all of this can only be done if you have powerful automated contracts, smart contracts that can enforce that all the steps are done properly. Second thing, we need to manage non-fungible assets. What are non-fungible assets? They are assets that are unique and indivisible. It means no two assets are the same. This, for example, is true for chunks of data that providers produce. Each chunk of data is a unique asset, and it is indivisible, and it can't be split, it can't be copied, it's just one unique thing that exists. And that is also true for the code of the tasks on the other side. But then we also need to manage fungible assets. Fungible assets are those that can be divided and are indistinguishable from each other. Think money. €1, a €1 coin is a €1 coin, and it doesn't matter if you have €2 coins, they are exactly the same. They are indistinguishable, and they are divisible in the sense that you can have instead 2 50-cent coins. And this, of course, is the perfect way to manage currencies and to manage various other tokens that can be used to reward the providers for their services. So we need to manage all these things. And so we need a blockchain that allows to have all of these. And among the many that exist, we have identified Ethereum as the most suitable for this job. Why? Because it provides standards and tools for doing each of these things. And also because it is a very well-established blockchain with a mature ecosystem. And so it's a strong option for having a reliable platform. And so, yeah, so this is our third building block. Now, with this, I'm done with the main building blocks, but there are a number of other things that must be kept in mind. And we put this down as open challenges. And these are other aspects that maybe do not seem that prominent, but that they are fundamental in any implementation to ensure that all the requirements are met and that the implementation can actually be used correctly. So the first one is about rewarding schemes. So the question is, I as a company have a budget to run a workload. How do a budget in terms of rewards, and how do I split that among the users who provide the data? Is it something like we give the same reward to all participants, 1 over the number of participants? Do we do instead based on the amount of data? So if one participant gives more data, then we give them a higher reward. This seems pretty easy and reasonable, but then is it really the best and the most fair way to do it? Is all data in the system worth the same? And maybe the answer to that is not. And one maybe might start thinking, can we do rewards based on the added value of each provider? So I get paid based on how much value my specific data generated to the task that the company ran. And this seems very fair. However, it is hard to establish what does that mean, hard to compute how important each specific data point was to the task. And also, until you run the task, you don't know how useful each data point was. So users would have to participate without knowing in advance. They would know what kind of range of rewards they would get, but they would not know the exact value until the task is done. So yeah, this is one problem, not easy, not obvious to solve. There are ways, there are techniques, however, more work needs to be done to decide which one is the most suitable and to find the exact trade-offs. Second point is data authenticity. So I, as a data provider, especially if the reward is based on the amount of data, I could think, well, you know what, I'm very good at generating random data. I can just put a computer there and generate as much random data as I want. I can forge fake data, have more data, and get more rewards. So, of course, we want to prevent this as much as possible. One possible way to do is by using cryptographic signatures. So Fitbit data must be produced by a Fitbit, which internally will sign all the data and guarantee, yes, this data came from inside this Fitbit. This is not a bulletproof technique. There are ways to circumvent it, but it's a good starting point. And of course, not having rewards based on just the amount of data would also help a lot in preventing this. Another thing is data replication. So this is another approach. Instead of generating fake data, if I can generate fake data, I can just take my real data and just send it to multiple executors and just hope that if no one notices, I can get more rewards. And this can instead be prevented by using, in a smart way, blockchain technology to validate that non-fungible assets are not duplicated in the system. They are not copied they're not given to more than one position, one place at the same time. But again, more work needed on this, and more work also needed on our next slide of challenges. One is indirect privacy leaks. So what does it mean? Well, our nice trusted execution environments and decentralized aggregation guarantee that no one can directly see your data, but the result of a task can already give some information out. And there are works that have shown that, for example, machine learning models can be reverse engineered up to a certain degree to extract information from the users, to extract information about the input data. And companies could even try to do this on purpose. So how can this be prevented? One way is to use static or dynamic task analysis to analyze the tasks that are being submitted to PDS Square. And by doing that, what we can do is that we can basically identify if there are things inside the task that are there to leak data, or that can increase too much the chance of leaking data. And we can prevent these tasks from being run, or we can tell the consumers, tell the providers that these tasks are very risky. Or another technique, it's not exclusive, so they can be together. Another technique is to inject noise in the results, so similar to what differential privacy consists in. So once the model is trained, the executors can inject some extra random noise, change all the weights a little bit before submitting it to the consumer to guarantee that it's even harder, if not completely impossible, to extract any user information while still maintaining the overall quality of the model. Finally, last challenge that I will consider is data discovery and filtering. So we said how the storage subsystem uses metadata to identify eligible data for each task. So if a task requires Fitbit data, storage subsystem will verify, does this user have Fitbit data? But what if the consumer asks for something like this? I want Fitbit data of people who were running outside when the ambient temperature was less than 5 degrees Celsius. Now, this is a very specific request. And can we fulfill it? Can the storage subsystem verify whether the data fulfills this request? Well, this is hard because, again, the data is hidden from the storage subsystem. Storage subsystem only has metadata. And of course, if you put all this information in the metadata, then the metadata itself is leaking your privacy because it's giving too much information about what exactly you did. So yeah, there is a trade-off there. And to be fair, even if there was no privacy leak in the metadata, the fact that I participate in this task, the fact itself that I have data that fulfills this request already tells a lot about me. Because it's not just I own a Fitbit, now it's I own a Fitbit and I go running when the outside temperature is less than 5 C. So an alternative to this kind of metadata usage could have to be to let the executors do the filtering. So I send all my Fitbit data to the executors. The executors will then, in their privacy-preserving data computation, check which data matches the request, only use that data for the training, and then reward me based only on that data. However, this is, again, computation expensive, and both the eligibility of my data and the rewards I will get are not known in advance. I don't know that until my data is actually submitted to the executor. So I'm participating in the training without knowing how much data I will get paid, be paid for. So yeah, these are things that we are working on and that we will need to tackle for any implementation of PDS Square. So now quickly going through the conclusions. So what is PDS Square then in a nutshell? To summarize, so I will use this sentence. I think I stole it from something that Thomas wrote. So PDS Square is a user-centered, decentralized data marketplace for privacy-preserving data processing. And now I will not repeat all the requirements we went through before. I will just highlight some things about PDS Square. The first thing is that we are not reinventing the wheel. Everything we are doing is built on existing technology. What is new is the way we bring these technologies, we bring these different research areas together to achieve a series of complex requirements. Also, talking about requirements, requirements have been driving our entire work. We started with a very simple sketch that was something like, yeah, decentralized machine learning training, great. And we evolved these to accommodate all needs. So really, it might look as complex to some people, this design, but really every part that is there is not motivated by, hey, I like this. Rather, it's motivated by the fact that it's needed to solve some of the issues or to fulfill some of the requirements. And the last thing that I'm personally very proud of is that PDS Square is a very modular, flexible, and extensible architecture, because we know that new technologies will come out, new trusted environments, or new super efficient homomorphic encryption, or new gossip techniques will come out. And so it's important that our architecture can be implemented with any new technology, and all the guarantees that we provide will be there as long as the technologies we use fulfill their basic requirements that we discussed. So again, this is a model that allows us to easily verify a lot of different potential implementations. And also because the needs of the people, the needs of our users might change over time. So last thing, what is the status of the project right now? Well, we have defined the high-level architecture of PDS Square and the interaction between the main components. We have identified, and I already presented it to you, all the most suitable technological solutions right now to implement PDS Square. And we have drafted now a vision paper, which will be submitted for peer review in 1.5 weeks from now, January 25. And hopefully it will be accepted, and it will contain basically what I explained to you today, what I presented you today, with more or less the same structure. And we believe this will be basically the starting point for then all the future work that we are planning, which of course includes a proof of concept implementation of PDS Square, which will be needed in order to test, first of all, that we didn't go crazy and that this is actually something doable. And secondly, test and evaluate all the different technologies that we can use for each component. So evaluate and find out if we really got the correct technologies and how we can optimize them and what changes we can do to make them work even better. Then we plan to do follow-up work on, actually not then, but in parallel, follow-up work on each separate component. And this is actually a good thing about the modular design. We can actually then split and take smaller components. We know their requirements and we can work on each of them independently. So yeah, basically each of us, based on expertise and interest, will work on something slightly different. And also this means that anyone can read the paper and based on it design additional components that can plug into this modular architecture, or design different implementation of the main concepts, of the main aspects, based on their expertise or based on how they want to use it. So this is why it's very important, it's modular and very flexible design. And now, after this quite long presentation, I think I can thank you. Thank you for your attention. And if you have any questions, please feel free to ask.
Thank you very much, Ludovico, for the interesting presentation. Are there any questions? And also, sorry, just to say that good luck with the paper submission. Okay.
Thank you, thank you, thank you.
So I have a few questions.
Yes.
So one is that What I didn't understand, if you sell this architecture as totally decentralized, or you allow some components to be centralized or semi-centralized, and in that case, which ones can be semi-centralized and which one can be centralized?
Yeah, so
I mean, one option is to sell it as completely decentralized, and that's it. But then it might be a bit of a, you know, not easily achievable. To make it more easily achievable, you could say that some of them, or I mean, maybe all of them could be, say, centralized, and you can turn a knob somehow from completely decentralized to centralized.
Yeah, so it is indeed, as I said, very flexible, so you can definitely configure in any way you want. Of course, we believe the more decentralized, the better. Also because there are some advantages that come from decentralization. In particular, when I discuss the different aggregation strategies, if you go with a fully decentralized aggregation strategy, then you get the most benefits from the kind of scalability that you have, the usage of the computational resources and bandwidth. But actually, the aggregation strategy is also the best place to actually discuss this, because yeah, you can have hybrid approaches there. You can go with federated learning. You can go with some kind of hierarchical system with different layers of federated learning on top of each other, kind of tree-like aggregation. You can go with all of these, but there is one important caveat. You must make sure that you address, and now we'll go back forward to that you address these issues. You don't need to address scalability, that's just a nice to have. But these other two issues, they must be addressed. So you can't have pure federated learning, as I described it here, where the consumer becomes the aggregator, because that would be not transparent, not auditable, and it could leak privacy. So you could have partially centralized solution. You could elect one of the executors as the leader, and you could let the leader do the aggregation. That is indeed possible. That would count as a semi-centralized solution, I believe. You would lose scalability. You would not lose these two. You would not lose fairness, transparency, auditability, and privacy, which are the really mandatory aspects of it. So yes, it is possible to go toward centralized techniques. Even for the governance layer, no one prevents you from having a Raspberry Pi in your office being the governance layer for the entire system. But maybe you don't want that because you need to guarantee that all these fairness and privacy, they are maintained. So
I am not questioning that decentralized could be the best. I'm more concerned when if you want to make a proof of concept, it might require several steps until you arrive to say fully decentralized. And then in a sense, the question is which parts you would centralize first and which would still be, say, centralized. Maybe, you know, you could have a decentralized aggregation, but the governance layer, you could make some kind of a trusted central party or a third party or something. So it's in a sense, I'm not anyhow saying that you know, it's not complete, but it's how you sell it. If you sell it as that's, you know, the vision for the complete decentralized, it's fine. But if you sell it as that it's totally flexible, where some components or each component or the set of components can be tuned to the level of centralization, then maybe it has to be articulated in the paper. I mean, this is more of a, if you want to articulate it in the paper more.
Yeah. Indeed, we sell strongly this flexibility aspect, this modularity aspect, the fact that we can have different technologies. To be fair, we mostly focused on different technologies that are not centralized, because even in the decentralized field, you can have different technologies. But yeah, you could have solutions that are less decentralized, and those will be perfectly fine. You still maintain just that minimum decentralization that guarantees you these things. You could also go centralized, and this is something we didn't say in the paper, we could definitely mention it. You could go and have something that is centralized and non-auditable, as long as you then put a trust requirement that you must trust it. So as you said, you can have a centralized governance if you trust it, or you can have a centralized governance if you use some technology to guarantee that that centralized governance can't cheat. So if your centralized governance is run on a trusted execution environment, for example, I would just say that because at a first glance, it appears it can solve any problem, although when you go into the details, it doesn't. With that, you could guarantee that the central governance computer is actually running the correct code and not random things. So you can definitely, so the thing number one is flexibility, and decentralization is the easiest way, at least theoretically, to achieve all the requirements. But there are other solutions. And yes, we are open to different, more centralized implementations.
So I don't know how much is achievable for the submission, if it is, I mean, it's pretty soon, but I somehow was, could be nice to have some kind of, I don't know, a table of use cases where in one side you have everything central, and then you have the certain assumptions. That means you lose this and this properties, and you have to have this and this assumptions. Another, maybe the last column is everything decentralized, and again you have a certain assumptions and certain properties to preserve. And then maybe in the middle, one or two or three, I don't know, some combination where, as we discussed, say governance layer centralized, aggregation decentralized. You assume this and you get that. Sort of some extent that you're not imposing that everything has to, it's all or nothing. But given the circumstances for some certain, environments or domains or something, maybe you do not need to go all the way decentralized. And in that case, you need to wait until all these open challenges are solved and the technology is developed. Maybe you can even go quicker and not go maybe for the first naive or not naive, like a default layer of a centralized stuff, but you can trade off certain things and still get the best of the whole of these worlds, even though the final sort of technologies are not there yet. So this could, maybe we could think if it's still, I know that your paper is very, it now lacks, you need to shrink it rather than to add stuff, but maybe for the future iterations could be nice to have this type of discussion on the possible use cases and with what you get and what you lose and what you trade off.
Yeah, and in general, I think actually it's a very good idea to, I don't know, again, I don't know for the paper, but it's a very good idea, yes, to have this kind of spectrum of possible implementation, possible trade-offs between complexity and characteristics and properties that you get or that you lose, or how much trust you need to put, or how many complex technologies. So yeah, that is actually a good suggestion for something that we can prepare for future presentations and for future publications.
And that also would relate. Yeah, sure, go on.
Okay, just go, Professor, and then I will ask my question.
So I just wanted to add is that this also is a little bit in line is how what you call users or actors. I mean, that's another thing, a bit semantics. So there are, so say the system has some users, which they can be companies, and they take some roles, which could be these executors, storage, data producers, the whatever, and they could be of different subsets. So say maybe could be a third-party storage, another third-party executor, and then this consumer. So everyone is separate, or maybe most of the people are the same, or maybe again, do you allow the data consumers to be executors or not? Or the executors has to be either third party or should be the producers? I mean, what are the combinations that are valid and which are sort of not allowed, or anything is allowed? And so that's another thing. And maybe for the paper also, I would suggest to minimize the number of notations, because somehow you also introduce in the paper players, which is fine, but also then it, for me, when you say players, then something like game theory kicks in. And maybe this is not much of a game theory here, unless you go to the reward schemes. But again, this is more like an open challenge rather than the. So I think this could be also a bit more pruned in a sense to the bare minimum that is required to. So I would say I would keep some kind of actors and roles only, not to have any more sort of this different notations that then it's not anymore clear what could mean what and what could take which role. Sorry, so that's my current comment. So Ahmed, if you wanted to
Okay.
or maybe Lodovico, you wanted to comment something on my.
I would just make a quick comment. Yeah, so right now, for how I presented it and what we brought until now, anyone can, any actor can assume any role because we have the technology to ensure that nothing breaks. However, again, if you start removing some of these technologies or making things more centralized or basically, yeah, reduce the technological layer, then you must start putting limitations like the executors can't be consumers. Otherwise, they can collude to see the data if you don't have a way to prevent it. So with the technology we described, we don't need to put limitations. But again, it's again a spectrum. You can put more limitations and reduce the technologies that are needed. And for the players and things, yeah, I refrained from using the word players in this presentation, but they are players. And at some point, the game theoretical aspects will become fundamental. It's just we didn't tackle that part in detail yet. So yeah, this is my answer. And Ahmed,
okay, so yeah, I guess Professor Sarunas talked about a small point that I want to expand on regarding the rewards. Do you have like an idea about how would you manage these rewards? I'm not even talking about their fairness or not, but like how do you give value to, yeah, it's, yeah, this added value. You talked about the added value there. What is the value that backs up, for instance, the reward? Or and again, as Professor Sarunas mentioned, the game theory would play here as well. So I didn't really understand what backs up, because if we are talking about rewards or incentives, there is always something that backs it up. So in this case, what it is?
Yeah, so the idea, I think I will give an introduction, then I will let probably John go into more details. I've seen he switched on his camera, and he is the person who is looking more into the details of how rewarding schemes work. But so the general idea is that right now companies, they are producing a lot of value from their data, and they are spending a lot of money in infrastructure and computation to actually extract value from the data. And what we provide is that instead of spending the money there, they spend the money to get the data and run the execution in our system. And so the idea is that part of the value that the company producing from their data goes back to the users that generated the data in this way. And so that is where the money comes from. And then the question of how the money is split from one consumer to multiple producers, that's where the question here comes up. And that's where, if you want to go to this idea of added value, then you need more game theoretical aspects and more advanced aspects on how to compute these. And if John wants to give some details on this, I think he is the best person to talk about it.
Hi. Basically, what I want to add is,
hello.
It's not only one thing that you can use, only one that you can go with in order to reward the sellers of the data. But the thing is, which one is more is better for the context that we're working on. And it seems that, for example, the one from game theory that we are considering, at least it provides fairness on how the reward is going to be split. Then again, it doesn't define the exact value of the data, so how much the data set actually costs. Then we have to go to search in more economical aspects, to search into the demand and the supply curves to actually determine the exact price of the data set. But how to uh, to measure the contribution of each user, then game theory provides a solution to that. Although it's not the best solution, but it provides one solution. Another approach, for example, is instead of go and price data, you can go and price a model. So you have pre-trained models, and then depending on the budget of the user, of the consumer, then you modify the accuracy of the model. And then there are other solutions. For example, there is the query-based model that you go actually and charge by how much information are disclosed every time you query from a database. For example, I don't know if this doesn't seem like the best solution in our case, but it's another approach. But in general, we have to take into consideration also the decentralization aspect of our system and try to determine which one is better, and also what kind of configurations and modifications we need to do on each approach to be more suitable for our system. And that's why it's still an open challenge. It's not that easy. I don't know if this covers.
Yeah, thank you. Thank you for the clarification.
And I'm not
of course,
sure
thank you a lot of people for the very interesting presentation.
Thank you.
I'm not sure if you discussed, but its reward should come not only to the data producers, but also say to the executors and to the storage layer. And
exactly.
And this again could be different entities.
Yes.
So as incentives to work fairly in the system, but also for their work. I mean, it makes sense from the game theoretical aspect as well to give them rewards.
But then again, maybe you could argue that this could sort of the systems could work in the whole range of spectra, from fully volunteering Wikipedia style, system where people just happy to go and contribute as long as they don't see the big IT companies and their data is private, and so maybe in some cases this could even work out without financial incentives, as long as the system is decentralized and sort of fair to start with. And of course, all the way to very complex game theoretical approaches where you would calculate the exact amount of the benefit of my data that I gave to the model, and then how this model was used, and then whatever the money came back to me. So that's, I think, it's a very large range of sort of the way the system could be used. And maybe we can also start motivating that. Let's just assume that initially people are happy to volunteer.
Yeah, I mean, we have, there are examples in the wild of people volunteering computation and data for achieving some good
noble
things.
causes.
Yeah, exactly. That's the word I was looking for. Yes, of course. Although that would be quite limited in the scope, of course, because then no one would give their money, their data to a business entity for free. So another thing, once you go to have no longer volunteering, but you have rewards, then it's important to consider the rewards for all the participants, as you noted. Also, you have to consider the overall, the feasibility of the system as a whole, meaning that in general, it must, for example, the most visible part is it must make sense for the company to spend money in this way rather than spend it in the alternative way, which is I collect data in my own data centers. And here you have to consider, does it make sense, not just from a financial point of view, because it might be more expensive financially if it provides added value. For example, the fact that I can access any data without having to collect it for many years in advance. So yeah, it's also, and that's something that is hard, even in a proof of concept, it's something that is hard to test. For testing that, you need to actually try to deploy it large scale, and you need to have people with economic background who are able to actually reason about it. But so it's important, yeah, that it makes sense financially and non-financially. So all the incentives must be the correct values. So not just fair way of dividing the rewards, but the total amount of money flowing in the system, and must be reasonable. So the consumers must be willing to make that money flow there, rather than making it flow to their data center to buy more hard drives for storing more data, for example. So it's the economical dynamics are quite complex, and frankly, we might lack some expertise for the more advanced part. So we can work on the fairness of the rewarding. We have game theoretical background. We do not have actual economics background to then verify whether a large scale deployment would work. And that could mean that we might want to have a collaboration with someone with an economics background in the future to go into the more details of this.
But start from simple things. Assume that people are volunteering and there is no company, but there are a community of the people themselves who want to train the model. So they just do it for their own sake and without involving Google or Facebook. And it's not difficult to motivate, especially now with all the WhatsApp change in privacy settings and you know what's going on. And so I think it's not that far-fetched that people might just be willing to, you know, to do this noble cause of making something similar to Facebook, just decentralized, or some other service that is now centralized.
Yeah. Of course, with the proof of concept, we will start small, we will start simple, and then grow it as we go forward.
Very good.
Nice. Do we have any more questions from the participants? Okay, this is